Okay, just a quick word about current and electron flow. Now, in this diagram of a circuit, you'll notice I've drawn in a battery, and it's got a positive end and a negative end. Now, so far, we've been talking about the fact that it's actually electrons that flow around the circuit, and that's in fact the case. So the electrons will exit the battery from the negative end, flow around the circuit in this direction, and return via this end. But perhaps let's look at why this is the case and look at this from a historical perspective. A couple of hundred years ago, when they first were contemplating the idea of things flowing through wires with charge, they hadn't identified either the positive or the negative charge, what the actual objects were that were carrying those charges, and therefore they took a bit of a guess. They thought that something was flowing, but they didn't know whether it was positive or negative. And they took a chance, and they took a guess, and they guessed positive. Well, in fact, they were, in the case of a metal wire, they were wrong, because it's actually the electrons that are moving. So, if we have a bit of a look at that, then, and the reason why, in a metal wire, the positive charges are actually contained in the nucleus of the atom. And those nuclei are connected in basically a crystal structure or a lattice, and they're not free to move. They're stuck where they are. So they can't really move. On the other hand, the electrons, which are sort of swimming around between those nuclei, are free to move. And that's why it's really the electrons that are carrying that current, because it's the electrons that are free to travel through the wire. But we need to be aware of the fact that when textbooks talk about current, in many, many cases, basically in all cases, they're referring to the idea of an imaginary positive charge moving around the circuit. And so, if we talk about the idea of conventional current, and we'll knock this out now, conventional current, or even conventional current is the direction that a positive charge would flow around the circuit. And we probably know that would be in this direction. So that's the direction of conventional current or current. Current would flow, if it was able to flow, from the positive terminal around the battery back into the negative terminal. But we know, in fact, there's actually electrons flowing. And so we need to be aware of the difference between current and electron flow. Now, from a mathematical point of view or a calculation point of view, it makes no difference. Because if we, for example, had a current of, say 3.2 coulombs of charge flowing out of our battery per second in negative electrons, that would correspond to the same current value flowing in the other direction. So it'd be like an imaginary 3.2 amps of current flowing out in the other direction. So when we're using it in formulas and we're actually doing calculations, we don't have to worry about it at all, but we just need to be aware that the direction that electrons travel around a circuit and the direction of what we define as current are actually the opposite direction. So we just need to be aware of those two directions. And some questions they will talk about electron flow, other questions they'll talk about current. We need to know which direction each of those represents in our circuit. Okay.